So good morning friends, welcome to Water Resources Engineering class. In this lecture, let us discuss some of the quiz questions in Unit 1. Unit 1 mainly refers to the hydrology. What is hydrology? The hydrologic cycle, right? After the hydrologic cycle, mainly precipitation. The entire Unit 1 represents regarding the precipitation. Let us see some of the questions in this. What is a hydrologic cycle? The hydrologic cycle is the continuous process by which water circulates through, what are the processes? Evaporation from oceans and land, condensation to form clouds, precipitation as rain or snow, and runoff returning to the oceans. This is the cycle. It maintains the Earth's water balance and supports all hydrologic phenomena. What are the main components of hydrologic cycle? The main components of hydrologic cycle are evaporation, transpiration, condensation, precipitation, then into the ground, infiltration, percolation, and runoff. Finally, whatever you see with your eye is the runoff. Each process represents a phase of movement and transformation of water in the nature. What is global water budget? The global water budget refers to the balance between the total quantity of water evaporated from the oceans and land and the total precipitation received. It ensures long-time stability of Earth's hydrosphere through equilibrium inflows and outflows. Once again, the global water budget refers to the balance between the total quantity of water evaporated from the oceans and land and the total precipitation received. Right? It ensures long-term stability of Earth's hydrosphere through equilibrium between inflows and outflows. What is the significance of hydrologic cycle in engineering? Engineers use hydrologic cycle concept to estimate what? Runoff, flood magnitude, groundwater recharge, and reservoir design. It forms the foundation for water resources development, irrigation planning, the drainage design. Define precipitation and mention its importance. Precipitation is the process by which condensed water vapor falls to the ground as rain, snow, hail, or dew. It is the main source of fresh water for rivers, for lakes, and groundwater, and it is very much crucial for irrigation and water resources planning. What are the main forms of precipitation? The main forms of precipitation are rain, drizzle, snow, sleet, glaze, and hail. In India, rain is predominant form accounting for nearly all surface water availability. What are the main types of precipitation? Forms of precipitation. The next one is what are the types of precipitation? Cyclonic, which is frontal precipitation, convective precipitation, orographic precipitation, non-frontal precipitation, and precipitation due to turbulent ascent. What are described the characteristics of precipitation in India? India experiences mainly the monsoonal rainfall. That's all. With about 80% of total precipitation occurring between June and September. 80% of our precipitation is mainly between June and September. It is highly variable both spatially and temporally. With the time it varies, with the space it varies actually, causing floods in some areas and droughts in some other areas. What are the different types of rain gauges used in India? The different types of rain gauges are non-recording rain gauges, recording rain gauges. Non-recording rain gauge is Simon's rain gauge, and whereas recording rain gauge is tipping bucket, weighing bucket, and float type. The Simon's rain gauge is most commonly used in India. Differentiate between recording rain gauges and non-recording rain gauges. A non-recording rain gauge simply measures the total rainfall depth over a period, while recording rain gauge actually continuously records the rainfall intensity versus time using mechanical or electronic means. What is a rain gauge network and why is it important? A rain gauge network is a system of multiple gauges installed across a catchment. You take a particular district, a catchment area, number of rain gauges that are installed in the catchment, that is what we call it as a network of the rain gauges. Its proper density ensures accurate estimation of mean aerial rainfall, which is vital for a hydrologic and flood analysis. Explain arithmetic mean method for estimating average rainfall. It is nothing but actually if you simply take sum up all the things divided by the number of gauges actually. It is nothing but the rainfall recorded by each of the gauge divided by number of gauges is what we call it as average precipitation by arithmetic mean method. When this method can be used when the rainfall distribution is uniform and the gauges are evenly spaced, then this method is suitable. What is Thiessen polygon method? In this method, a catchment is divided into the number of polygons actually and around each rain gauge. So that means the area surrounding which is nearest to a rain gauge is isolated. So that's then each gauge rainfall is weighted by its polygon area. This method gives more accurate results even though they are unevenly spaced. Explain isoheightal method. In this graphical method, isoheights are drawn. What do you mean by an isoheight? Isoheight is nothing but the line of equal rainfall, and the average rainfall is computed by considering the areas between two successive isoheights. It provides most accurate estimation for non-uniform rainfall. How is missing rainfall data estimated? If a station's rainfall data is missing, it is estimated using the data of the nearby stations, either by using arithmetic mean method or normal ratio method, which is also called as inverse distance method, depending on the variation in average rainfall between the stations. What is meant by consistency of rainfall records? Consistency means a rainfall record at a station remained reliable and homogeneous over time. It is verified basically by using the double mass curve technique, comparing the cumulative rainfall of that particular station with all the neighboring stations. Explain depth area duration relationship. The depth area duration relationships shows that the rainfall depth decreases with increase in area and increases with its duration. It is used for estimating design of storms and flood analysis in hydrologic studies. What is the intensity duration frequency relationship? It is basically expresses the rainfall intensity as a function of its duration. Not only the rainfall intensity not only is a function of duration, the rainfall intensity is a function of recurrence interval also. It is essential for stormwater drainage design and flood forecasting. Excellent thing, flood forecasting. What is define the probable maximum precipitation? It is the maximum greatest depth of precipitation that is meteorologically possible over a given area for a specified duration. It forms the basis for the design of critical hydraulic structures such as dams or spillways. What are the sources of rainfall data in India? The rainfall data in India is primarily collected by the Indian Meteorological Department, Central Water Commission and state irrigation departments, and using the standard gauges and what you call it as synoptic basically stations. State the monsoon season in India. The monsoon seasons in India are basically the southwest monsoon, which is June to September, whereas the northeast monsoon is October to December. Winter season is January, February, and pre-monsoon or hot weather season is March to May. What are the engineering applications of rainfall analysis? Mainly rainfall analysis helps in designing the storm sewers are nothing but the pipes, estimating runoff, flood control structures, irrigation scheduling and reservoir capacity determination, ensuring safe and efficient water resources management. Basically the analysis of rainfall is for safe and efficient water resources management in terms of the design of storm sewers, actually estimating the runoff, actually the flood control structures, irrigation scheduling and reservoir capacity determination. So these are the 20 questions actually which we are having. So now let us go into some of the formulae which are absolutely necessary for solving any problem in this particular unit. So what are the problems that you come across in the first unit? In the first unit, the problems that you come across are: number one is how to estimate the optimum number of rain gauges. So normally in any problem, they may give you what are the some number of gauges actually. Whether those rain gauges are sufficient to measure the annual rainfall or the rainfall, basically average rainfall or daily rainfall, that those are sufficient or not. That network is sufficient, or shall we increase the things? So this is the question that will be asked to you. In such a case, the optimum number of rain gauges as per the ISI is N is equal to CV by epsilon whole square, where CV is nothing but coefficient of variation which you can calculate using standard deviation and mean, whereas epsilon is something naturally that should be given in the question, how much error you can permit. Epsilon is nothing but the design degree of error in estimating the average rainfall. So how much you can permit, that is the thing. So epsilon will be given to you. You need to find out what is CV, and then once CV is found out, you can find out N. How to find out CV? CV can be found out if you determine the standard deviation and the average precipitation. So average values, you can determine the average value is the number of whatever the number of existing rain gauges, the sum of the rainfall values divided by basically number of rain gauges. That is the average precipitation. Standard deviation is how much actually the rainfall is varying from the mean. This is the P bar is the mean, and rainfall at any station actually. So if you sum up or the square it and sum up the whole thing divided by number of rain gauges minus 1 under root, if you put it, this is the standard deviation. If you put it only square and sum divided by m minus 1, that gives you variance. Then square root of variance gives you standard deviation. Once a standard deviation is known, once the average precipitation is known, calculate CV, and once the CV is calculated, then calculate N. So this is one question, common question, which generally will be asked in this particular unit. Then what is the second question? How to estimate the average precipitation? There are three methods for estimating the average precipitation. One is arithmetic mean method. The second one is Thiessen-Polygon method. Third one is the isoheital method. In the arithmetic mean method, just like whatever the number of rain gauges that are there, the rainfall values are there, take the sum of it and divided by the total number of rain gauges. That if you put it, you get by the arithmetic mean method the average precipitation. But this is absolutely correct if provided the gauges are evenly spaced and the rainfall is uniform actually. And if suppose the next method is better method than the arithmetic mean method is Thiessen-Polygon method. In the Thiessen-Polygon method, what we are doing actually, if suppose you take, there are 4 stations, for example, here there are 4 stations. This is one station, second station, third station, fourth station. So what we do, it is this is 1, 2, 3, 4th gauges. So you are having values P1, P2, P3, P4. And to this total area, now you divide into, by drawing the perpendicular bisectors, you divide the total area. So P1 represents this area. This area is represented by this gauge, and this area is represented by this gauge, and this area is represented by this gauge, and this area is represented by this gauge. So that's why P1 into this, if I classify, this is A1, A2, A3, A4, P1 A1 plus P2 A2 plus P3 A3 plus P4 A4 divided by A1 plus A2 plus A3 plus A4. So that is what I have written it. This is nothing but 1 by A into sigma I is equal to 1 to n number of gauges in sigma of Pi into Ai. So the P1 into A1, P2 into A2, P3 into A3, P4 into A4. That is what which we have written the Thiessen polygon method. So isohedral method is so if I write the equation, it is nothing but P1 A1 plus P2 A2 plus P3 A3 plus P4 A4 divided by A1 plus A2 plus A3 plus A4 is nothing but A. So this A1 by A or A2 by A or A3 by A or A4 by A is called as area factor actually. That is what we call it as the weight, right? So that you should know. Isohedral method means what is the isohedral method? If suppose you take it a particular area. So naturally these are the values of equal rainfall. So this one, I call this line as isohed. The rainfall actually along this line everywhere it is same. Then these are the isoheights which we have to draw. Then naturally find out what is the area between the two isoheights. This is the area between the isoheights. Use a planimeter and find area between the adjacent. For example, this represents a rainfall value of 10 and this represents a rainfall value of 12. And for example, this is A1. So this A1 into 10 plus 12 by 2 basically. So how much it is? A1 into 11. So like that for each thing you do it basically divided by the total area. Area between two adjacent isoheights into mean of the two adjacent isoheight values divided by the total area. So this is the third method. So the second problem is regarding the determination of basically the what you call it as average precipitation, and most commonly here normally in the exams both the isohedral method and Thiessen polygon method are very important. You need to practice these two methods very seriously. And coming to the third problem actually in this topic is the estimation of the missing rainfall data. So this is the third problem which you can expect. Well, for the missing rainfall data, what is more important actually, you need to check the given data actually. There are two things in that. One is they will give you actually the rainfall values actually P1, P2, P3 like that. They give the rainfall values, and again they give you normal annual precipitation. Normal annual precipitation, that is N1, N2, N3. So like that if they give it. So what we need to check initially is don't bother about the precipitation. Just go into the normal annual precipitation values. If the normal annual precipitations of basically the values are not deviating more than 10%, if the values are all within, for example, the normal annual value here it is 100 for example, here it is 95, here it is 105. So the variation if you see is less than 10%. If the variation is less than 10%, then at the missing station, what is the rainfall is equal to the sum of the rainfall values at other stations divided by the what you call it as wherever you are, what is the number of stations which you have. So this is the first thing. So when this method can be used, if the normal annual precipitation does not vary more than 10%. That means the variation is less than 10%. If the variation is less than 10% actually, right, then naturally you can go it. If the variation of normal precipitation is less than 10%, go for arithmetic mean method. If the variation is more than 10%, which variation, gentlemen? The variation is in the normal annual precipitation of the adjacent stations. If that is the case, you go for the normal ratio method, and that for normal ratio method already I have given the missing rainfall data, that at station X is equal to Nx by M into P1 by N1 plus P2 by N2 plus Pm P3 by N3 and so on. So this is the second. If the normal annual precipitation variation is less than 10%, arithmetic mean method. If it is variation is more than 10%, this is the normal ratio method. So these are the three problems which can be given to you. So kindly prepare these three problems here. And fourth one is the double mass curve technique. That problem also can be given, but at your level, because of the constraint of time, naturally they may ask in theory, but problem may not be given actually to you. Same is the case with the intensity, duration, frequency curves also, the DAD curves, depth, area, duration curves also, because there are also problems, but doing that problem within that stipulated time is for you it may be difficult. So naturally they may not go for problems of those things. What are those things? One is depth, area, duration analysis. That is one very, very important actually. Second one is intensity, duration, frequency, and third one is basically for double mass curve. So these three are also problems apart from the total. There are 6. Out of that, these 3 are commonly given because time also is one of the constraints, whereas the remaining 3 can be asked in theory. So kindly prepare well. Thank you so much.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.